Chapter number 4, Thermodynamics and the Gas Laws. In this lecture, we are going to solve the numerical problems. Now here some problems are given, and these problems are based upon the temperature conversion. Now the first thing is, for any type of calculation in this chapter, the SI unit of the temperature you have to take in SI unit of T, temperature, that is Kelvin. So the temperature you have to use in Kelvin only, not in degree centigrade. Don't do any calculation. Don't do any calculation of the temperature in degree centigrade. Every time you have to change this degree centigrade to the Kelvin unit. Now okay, now the problem number 1, the 100 degrees centigrade is equal to how much Kelvin? So what you have to do, whenever you are changing degree centigrade to Kelvin, so every time you have to add this number. This is 273.15. so this number always you have to add, and what the answer will come, that is in the Kelvin temperature. So whenever you are adding this 100 plus 273.15, so this is 373.15 Kelvin. So the meaning is, this 100 degrees centigrade temperature is equal to this 373.15 in the unit of Kelvin. They are same. Now the problem number 2, convert 20 degrees centigrade to Kelvin. So this temperature, this 20 degrees centigrade you have to change in the unit of Kelvin. So what you have to do, write your temperature in degree centigrade, then every time you have to add this number 273. So the exact number you have to add, that is 273.15. this is the exact number, but you can leave this decimal part for the simplicity. If you are not taking this, if for example, if you are adding 273 only and not taking this decimal part, it's okay, this is correct how I am doing in this example. Now here, whenever you are adding 27 in 273, so this will come 300 Kelvin. So this 27 degrees centigrade is equal to 300 Kelvin. The problem number 3, convert 2543 Kelvin into degree centigrade. So this you have to change this 2543 Kelvin. This is how much in degree centigrade. So this is opposite. Whenever you are changing degree centigrade to Kelvin, so in that number you have to add this 273 always, like this. But whenever you are changing the temperature Kelvin, sometimes you have to change according to the question. If the question is saying you have to change sometimes, so whenever you are changing the temperature Kelvin to degree centigrade, in this case you have to minus this number 273. So here what you have to do, you have to minus this here, and this is minus 273, and this is equal to, let me calculate this, 2543 minus 273, and it will come 2270. So this is 2270 degree centigrade. Like this you have to do. And now the problem number 4, In this problem, 32 degrees centigrade, you have to change to Kelvin. So what you have to do, In this 32, you have to add 273.15, and here you will get the answer. You have to solve this. I am leaving for you. Here, the problem number 5, the 18 degree centigrade, you have to change to Kelvin. So what you have to do, in the degree centigrade, you have to add this number, and what the answer will come here, that answer will be in the Kelvin unit. Problem number 6, compute the atmospheric pressure P ATM, atmospheric pressure. This ATM means atmospheric pressure on a day when the height of the mercury in barometer is 76 centimeter in bars. So in this, the question is saying you have to compute the atmospheric pressure. This P value you have to compute on a day when the height of the mercury, means like this is your barometer tube, like this is the barometer device, and this is the barometer tube, and here there is a one scale. So it means they are talking about this height, the height, this H. So this H is 76 centimeters. So the question is saying the height of, here there is a mercury, inside this the mercury is going up like this, and this is 76 centimeter. So this is the value of the height of the mercury. It means it is the value of the H in bars. So in bars means this pressure value you have to find in the unit of bars. So now in this problem, the readings are coming from the barometer. So for the barometer, the formula for the pressure, according to the barometer is, this is P equal to H D and G. So this formula we have to use for the pressure, and here this is the height. This is the height of the mercury, and this height should be in meter, not in centimeter, not in millimeter. And this is the density of the mercury, and this density is constant, and this will be given to you in the question. Like here it is given that the density of the mercury is 13,600 kilogram per meter cube. So this is constant here, it will be given, and this G stands for the acceleration due to gravity, and this G is also constant. This G is 9.8, this is 9.8 meter square, 9.8 meter per second square. So this is the value of the G. So this formula we have to use. Now here this 76 centimeter is, here this is 76 multiplied by 10 to the power minus 2, not 2. So this is minus 2. So here this is 76 into 10 to the power minus 2 whenever you are changing this centimeter to meter. So this is the value of the height of the mercury. Now here this P equal to, this is 76 multiplied by 10 to the power minus 2, and the value of the G is, the value of this D, the density is, that is 13,600, and the value of the G is 9.8. So you can solve this, and after solving you can get some answer here. So you have to solve. Okay, how much answer will come? So this answer will come, this answer will come in Pascal. This answer will come in Pascal, but the question says you have to find the answer in bar. So what you have to do here, your answer, what the answer you are getting in Pascal, so you have to change your answer in bar by using the relation between the Pascal and the bar. The relation between the Pascal and the bar is that 1 bar is equal to 10 to the power 5 Pascal. So this is the relation between the 1 bar. The 1 bar is 10 to the power 5 Pascal. So use this relation and then you change your answer. Now here the question number 7, what is barometer? So you have to define what is the definition of the barometer. Barometer is a machine which is used to measure the atmospheric air pressure. So this is the definition you have to give. Now the question says calculate the atmospheric pressure of the air in Pascal when the height of the mercury level is 65 centimeters. So this is the value of the height, and here the same formula you have to use for the pressure. So here you have to find the pressure, and the formula for the atmospheric pressure is, this is H D and this is G. So here this H is 65 centimeter, but this centimeter you have to change to meter, and this is the density of the mercury, and the density of the mercury is given here. So you can take this value from the above question, and the value of this G is 9.8 meter per second square, and you can find the answer, and this, whatever the answer, it will come here automatically. This will come in Pascal. Problem number 8, calculate the number of moles present in acetylene gas containing 4.8 into 10 to the power 25 molecules, and the value of the Avogadro number is given, that is 6.02 into 10 to the power 23 molecules per mole. So in this question you have to calculate the number of moles. So this number of moles you have to calculate, so it means the small n you have to calculate in this acetylene gas containing 4.8 into 10 to the power 25 molecules. So this is the value of the n, and this is given to you. So you can use the formula, n equal to, this is n over, this is n over Na. So here the value of the n is, that is 4.8 multiplied by 10 to the power 25 molecules, and here the Avogadro number, this is constant, and this is it will be given to you in the examination. This is constant, this Na, this is constant. So here this is 6.02 multiplied by 10 to the power 23 molecules. So you can calculate, and here what the answer will come. So you can calculate and you can find the answer here. Now the problem number 9, a gas contained in an 8-liter vessel at the temperature of 25 degrees centigrade and pressure of 10 atmosphere. Determine the number of moles of a gas in the vessel, and universal gas constant is given, the value of the R 8.3 joule per mole per Kelvin. So a gas is contained in a vessel whose capacity is 8 liter. So it means this is the volume of the gas. Vessel means a gas cylinder in which the gas is filled at the temperature of 25 degrees centigrade. So this is the value of the temperature, 25 degrees centigrade, and the pressure of 10 atmosphere. So this is the value of the pressure 10 atmosphere. Determine the number of molecule, determine the number of moles. The number of moles you have to find in the vessel, or you have to find number of moles of the gas which is filled in the vessel. Now this is a given data. So according to the given data, what the formula you have to use? The formula you have to use, that is, this is PV equal to nRT. So this is the formula that you can use to find the number of moles. And if I solve this formula, so it will become like this. So this N equal to, it is PV and it is divided by RT. So this formula you have to use for the number of moles. So in this formula, this is the pressure of the gas. This P is a pressure, this so this is the pressure of the gas, and this is the volume of the gas, and this is the number of moles of the gas, and this is the gas constant, and this is the temperature of the gas. So these are the parameters involved in this so here this we can use this formula, and you have to change this volume, in meter cube. So this is 8 multiplied by 10 to the power minus 3, and this is meter cube. So this way you have to change, and this temperature also you have to change. So this is 25 and plus it is 273. So after adding, how much it will come? So this is 298 Kelvin, and this pressure also you have to change. So this pressure is 10, and this is multiplied by 1.013 into 10 to the power 5 Pascal. So you have to use in Pascal, and all the values you put in the formula and calculate, then you can find the answer. Problem number 10. A sample of dry gas is found to occupy 3.65 liter at 22 degrees centigrade and 740 millimeter of mercury. And there are two parts for this question. How many moles of gas are present? So here you have to find how many moles are there. And in the part B, find the number of molecules present. So here you have to find the number of molecules present in the gas. So what the question is saying? The question is saying there is a one cylinder, and in the cylinder the gas, there is a one dry gas. Say this is one cylinder here, and in this cylinder there is a gas. These are the gas molecules. So the gas is inside this cylinder. This is the cylinder of the gas, and in this gas, the volume of the gas is given. This is 3.65 liter. This is the volume of the gas, 3.65 liter. So a sample of gas is found to occupy. So this is the volume of the gas. So I have written here volume. At what temperature? So this is the temperature of the gas given. So the temperature of the gas given here. the temperature of the gas is given here. This is 22 degrees centigrade, and 740 millimeter of mercury. So in this question, this information is very important. Actually, the question want to give the value of the pressure. So this is the gas, and this is the volume of the gas, and this is the temperature of the gas, and this is basically this is the pressure of the gas, but the pressure value direct not given. The value of the pressure is not given directly, it is given, this value is given in the form of the barometer data. So this value you have to found by using the barometer. So we say like that. Okay, if I have to say what is the pressure, so here the pressure given, this is 740 millimeter of mercury, we say like that. Okay, but this is not exactly pressure. Basically this is the barometer reading, and this is the barometer reading, and barometer reading means this is the value of the H from the barometer. So we use this language here, it is used, the pressure is 740 millimeter of mercury. So this is the value of the pressure, but this is not a direct value of the pressure, this is an indirect value. So what we have to do, we have to use the barometer formula, and by using the barometer formula we have to find the exact value of the pressure in Pascal, and here this is given in millimeter. So this we will find, and let's say here the pressure is given in terms of the height. So in terms of the height, this is 740, and this is millimeter of mercury. We say like this is the way to define the pressure, but it is here, it is in terms of the height of the mercury column. So this value is given here, and how many moles, so how many moles of gas, so how many moles of the gas means we have to find the value of the small n. Now see what the data given here. The data given for the A part, here this is the solution. So for the A part, the data is given, this is volume is given, and the volume is 3.650 liter. So this liter you cannot use, and this liter you cannot use, so you have to change this liter to meter cube, and by using the relation, this 3.650 into 10 to the power minus 3, and this is meter cube. So this way we can find the value of the volume. And now the temperature is given, this is 22 degree centigrade. So this you have to change by adding, so this you have to change by adding 273, and this is equal to 295 Kelvin. So this is the value of the temperature. Now here the value of the height given, so this height is, this is from the barometer. So this is 740 millimeter of mercury. So this we have to change, this millimeter we have to change to meter. So this is 740 multiplied by 10 to the power minus 3, and this way you can change, this is minus 3, and this is meter of mercury. It will come like this, and this reading is coming from the barometer. So you have to use the formula for the pressure, by using the barometer, and the formula is, this is P equal to H, D and G. So here the value of the H is, this is in meter, so this is 740 into 10 to the power minus 3, and this D stands for the density of the mercury, and the density of the mercury is given here. So I can take this value from the given data, which is already mentioned in the question. So this is the value of the D is 13,600, and the value of the G is 9.8 meter per second square. Now if I calculate here, so this will come the value of, so after the calculation this value will come 98. So this value will come 98627.2 Pascal. So this will come in Pascal. So this is the value of the pressure, not the H. So here we got this data, and we have to find the number of moles. For the A solution, for the A part, we have to find the number of molecules. Yeah, so we have to find the number of molecules, and we can use the formula to find the number of molecules. So this is ideal gas law. So this is ideal gas law we have to use, and the ideal gas law is, this is PV equal to nRT. So in this formula, the P stands for the pressure of the gas, and this is the volume of the gas, and this is the number of moles, and this is gas constant, and this is the temperature. So here we have to find the value of N. So I can rearrange the formula. So this N is PV over this is RT, and the pressure value is coming 98627. So this is 98627.2, and the volume is coming, this is 3.65 into 10 to the power minus 3. So this is coming minus 3, and it is divided by the R value. So R is constant, so this is 8.3 value of the R, and the temperature is coming 295. So this is 295. So let us calculate this number, and so after the calculation, the value of N, N is coming 0.147 moles. So this is the answer for the part A, and for the part B, find the number of molecules. So find the number of molecules means you have to find the capital value of the N. So here you have to use the Avogadro formula, and the Avogadro formula, here you have to use the Avogadro formula, the Avogadro's rule, and the Avogadro's, according to the Avogadro's rule, this is N equal to, this is N over, this is Na, and equal to you have to find this N you have to find. So this is N equal to N and multiply by Na. So this way you can find the value of the total number of molecules by using the number of moles. And here so here this is the remaining part of the part B, and this is the total number of molecules. So this formula you have to use, the N into Na, and this is 0.147 number of moles, and this the value of Na is given here. So this is 6.023 into 10 to the power 23, and after the multiplication, so after the multiplication this value will be 8.85. so this is 8.85 into 10 to the power 22 molecule. So this is the answer for molecule. So this is the answer for the part B. Problem number 11. This problem is based upon the STP. So before going to the problem, what is this, the meaning of the STP? This is standard temperature and the pressure of the gas. So we say the gas is at STP. So there are default values of the temperature and the pressure you have to take. You cannot take other values. So there are some default values, you have to take only those values which are the standard values, which comes under the standard values. So what this question is saying? This question is saying, if you want to keep 1 mole of an ideal gas, 1 mole of an ideal gas in your room at STP, how big a container do you need? So this question is saying, if you want to keep 1 mole means it is the value of the small n, the 1 mole of an ideal gas in your room at STP. So the meaning is the standard temperature and the pressure. So this temperature value you have to take, this is 273 Kelvin. This you have to take, and the pressure value you have to take for the gas, this is 1.013 into 10 to the power 5 Pascal. So these two values are the standard values of the temperature, and this is a standard value of the pressure. You have to take only this, you cannot take any other value. So these are the standard values. So the question says, how big container do you need? So how big container means, the question is asking what is the value of the volume. So now here the given is, the pressure is given because it is the standard value. So this is 1.013 into 10 to the power 5 Pascal, and the value of the temperature is given. So this is 273 K. So these two values we have taken from STP, the pressure value and the temperature value, and the value of the R is 8.314 joule per mole per Kelvin, and the number of moles are 1 mole, and you have to find the volume. And so according to this given data, what equation you have to use, what formula you have to use. So you have to use the ideal gas equation, and this is the ideal gas equation, and you have to rearrange in this form. So the volume is coming one side, and this you can find, and here what the answer will come, it will come in meter cube. Then after that you can change liter or any other unit, but this meter cube is the SI unit. So this is the SI unit of the volume. Problem number 12. A large cylinder tank contains 0.750 meter cube of nitrogen gas at 27 degrees centigrade and 1.50 into 10 to the power 5 Pascal. So this information is given about the gas. The tank has a tight fitting piston that allows the volume to be changed. What will be the pressure if the volume is decreased to 0.480 meter cube and the temperature is increased to 157 degrees centigrade? So this question is saying there is a one cylinder, and the cylinder contains 0.75 meter cube of the volume, and the temperature is 27 degrees centigrade, and the pressure is 1.50 into 10 to the power 5 Pascal. Now some changes are there in the gas. So the question says what will be the pressure if the volume is decreased to 0.480. Before the volume was this, and now the question says find the pressure when the volume is decreased to this and the temperature is increased to 157 degrees centigrade. So before the temperature was 27 degrees centigrade. So this we have to find the pressure value. So now here, if I draw the cylinder, and inside the cylinder there is a gas, the nitrogen gas. So this is the cylinder of the nitrogen gas. Inside this the gas is present, and now inside this the gas is present. Now the question is saying here the volume, this is the volume. So the question says the volume of the gas is 0.75 meter cube, and the temperature of the gas is 27 degrees centigrade, and the pressure of the gas is this is the temperature of the gas. This is the volume of the gas, temperature of the gas, and this is the temperature of the gas, and this is the pressure of the gas. So here the pressure of the gas is 1.5 multiplied by 10 to the power 5 Pascal. So this is the pressure of the gas. Now some changes are there in the gas. So they are saying if they are saying what will be the pressure of the gas if the volume is decreased to this one. So now the volume is decreased. If the volume is decreased to 0.48 meter cube, and they say the temperature is increased to this one. So here the temperature is increased to 157 degrees centigrade, and here the pressure. So the pressure you have to find. So here the two data is given to you. One side one data is given here, and the other side another data is given. So these are the initial values. This is initial values here, initial values here, and this is initial value. So this is the initial volume, initial temperature, and this is initial pressure. And here this is the final volume, and this is the final temperature, and this is the final pressure. So here what the formula you have to use here to find this, the rule you have to use the gas equation. So already I solved some problems, so on the basis of that you can solve this. And the formula you have to use, this is Pi, and this is Vi, and this is Ti, and this is equal to Pf, and this is Vf, and here this is Tf. So this one you have to take one side here, and what it will come, you have to write this side. Now before writing this one, you have to write all the parameters in the standard form. So in the standard form, so this volume already it is in meter cube, so this is in meter cube, no problem. But this degree centigrade you have to change, and this degree centigrade you have to change. Now here the Pascal, it is okay. Problem 13. Nitrogen gas is contained in a cylinder with a freely moving piston. So the question says there is a one cylinder in which there is a one pump, and the pump can go up and down. Having a volume of 1000 centimeter cube at 28 degrees centigrade and 6.5 megapascal expands until its volume is 2000 centimeter cube and its pressure is 4.7 megapascal. Find the final temperature of the sample assuming no losses during the process. So the question says there is a one cylinder, and the cylinder is like this. So this is a gas cylinder, and here there is one pump, or you can say the piston. So this piston can go in up direction, or this piston can go in the down direction. So this piston can move in up and it can move in down, and the gas is filled here. So the nitrogen gas is filled here, and the two data are given. The one data is the initial data of the gas given. So this is the initial data, and the another data given, that is the final data. So these two data are given. So here the nitrogen gas, the nitrogen gas contained in a cylinder with freely moving piston having a volume. So this volume, so this is the initial volume because it is coming first at 28 degrees centigrade. So this is the initial temperature of the gas, and this is the 6.5 megapascal. So this Pascal unit, it is for the pressure. So this is the initial pressure of the gas, expands until its volume. So now the gas is expanding, so this is another volume, bigger volume. So bigger another volume means it is a second volume, it is a final volume, like this, and its pressure is 4.7 megapascal. So this is the another pressure, and this is the final pressure. So find the final temperature of the sample of the gas assuming no losses during the process. So in this type of question, you have to use the gas equation, and the gas equation is this is Pi, and this is Vi over this is Ti, and this is equal to the Pf, and this is the Vf, and here this is the Tf. So this formula you have to use, and one side you have to rearrange the formula, and because you have to find the final temperature, so this and everything it will come here. But before putting the value of the parameter. So this volume is given in centimeter cube. Here this volume, it is given in centimeter cube, so this should be in meter cube, and this temperature cannot take in degree centigrade, so this temperature should be in Kelvin, and this mega you have to change. This mega is 10 to the power 6, so this you have to change, and here also this centimeter cube you have to change to meter cube, then you can use, and this also the mega you have to use like this, and everything is okay. So by using this formula you can find. Problem 14. Gas is contained in an 0.10 meter cube vessel at the temperature of 25 degrees centigrade and a pressure of 1.5 megapascal. What will be the pressure if the gas is allowed to expand to a volume of 0.15 meter cube at the same temperature? So here we have to find what will be the pressure. You have to find the pressure value. So the question is saying a gas is contained in this vessel. It means this is the volume of the vessel, or we say this is the gas of the in this vessel the gas is filled, so the volume of the vessel is a volume of the gas at the temperature of 25 degrees centigrade, and the pressure is 1.5 megapascal. So these three data are given. Now what will be the pressure if the gas is allowed to expand to the volume of 0.15 meter cube? So they are asking one pressure here given, so means which is given first. So this is this pressure is initial because it is given first, and this is this volume is the initial volume, and this temperature is the initial temperature. Now here this pressure of the gas, what will be the pressure if the gas is allowed to expand to the volume of this one? So this pressure is the final pressure, and this volume is the final volume. But the question says the pressure, you have to find the pressure value when the volume is increased to this value but at the same temperature. So in this process, when the pressure and the volume is changing, but this temperature is constant, this temperature is not changing, this temperature is constant. Other parameter here, the pressure is changing and the volume is changing, but the temperature value is constant. This is given by the question. So we can make an idea which rule we have to use. So the rule we have to use, that is the Boyle's law. Here the Boyle's formula we have to use here, because in the Boyle's formula the temperature is constant and the pressure and the volume is changing. So the rule, the Boyle's law rule is, this is Pi and this is Vi is equal to, this is Pf and it is Vf. So this formula is the formula for the Boyle's law, and because this formula you can use, I told you in my previous lecture, this formula you can use when the temperature of the gas is constant, otherwise not. So here you have to find the final pressure of the gas. So this final pressure you write one side, so here it will come, this is Pi and this is Vi over this is Vf. So here you have to keep the value of the Pi, so this Pi, Vi and the Vf. So this, and you have to, before putting the value, you have to look for the unit, they are in proper standard form or not. So this unit is okay, no need to change, but here this mega you have to change. This mega is 10 to the power 6. So this you have to change. This is okay here. Now by putting the values of Pi, Vi over Vf, you can find the value of the final pressure in Pascal. Problem 15. Problem 15 has the three parts, the part A, part B and the part C. So in the part A, identify which gas law is represented in the given diagram. So this is this diagram is given here, and you have to identify this graph is based upon which rule. So here on the y-axis there is a volume, and on the x-axis there is a temperature. So this is VT graph, and VT graph, we know the VT graph is for this is a VT graph, and the VT graph is used for the Charles law. The VT graph is used for the Charles law. So this is the answer for the part A. This is the Charles law. So this graph is for the Charles's law, like this. Now the part B. On the basis of the given diagram, give the mathematical relationship between the volume and the temperature. So how this volume and the temperature, they are mathematically connected. So the meaning is this volume and the temperature, they are directly proportional or they are inversely proportional. So if you see this graph is going upside like this. So upside means the temperature and the volume, they are directly proportional. So this is clear from the graph. If one parameter is increasing, so you can see from here, like this is you can see from here. So if temperature, this is temperature and this is volume, and if the temperature is more, 250, so the volume will be more. So if one parameter is increasing and the other parameter is also increasing, so it means both the quantities are directly proportional. Now for the part C, complete the given table. So this table you have to complete on the basis of the graph given. So let's go to the graph, and here. So now for the first, so here two rows are there. This is row 1 and this is row 2. So you have to fill according to the graph. Now here the volume is given, this is 300 milliliter. So what is the value of, here you have to write the value. So what is the value of the temperature at 300 milliliter? So this is the volume here, it is in the unit of milliliter, and this is 300 milliliter. So it is 300 milliliter and the temperature is coming 300 Kelvin. So here it will come 300 Kelvin. So like this you have to complete. Now the second one, at 400 Kelvin, at this 400 Kelvin, what is the value of the volume? So at 400 Kelvin, the value of the volume is 400. So this is 400 so at 400 at 400 Kelvin, so at 400 Kelvin the value of the volume is 400 milliliter. So this is 400 milliliter. Now here you have to find the ratio of the volume and the temperature. So this is temperature T here and this is volume. So here you have to find the ratio of V over T. But before putting this, you have to change this one. So this milliliter should be meter cube. So here this milliliter, so this milliliter you have to change to the meter cube. So how to change this? we have to, yeah, so look at here. So this is 300, so this is 300 milliliter. This milliliter should be in the unit of meter cube. So what you do, first you change this milli, after that liter. So this is 300 multiplied by 10 to the power minus 3. Now it is liter. Now this liter should be changed to meter cube. According to the relation between the liter and the meter cube, the relation is that 1 liter is equal to 10 to the power minus 3 meter cube. So by using this relation, this value will come. So this is 300 multiplied by 10 to the power minus 3. This is the number already which I have taken from here. And when we are changing this liter, so again I have to multiply by this minus 3. So this is meter cube here. So if I solve this together, so this will be 300 and multiply by 10 to the power, this is minus 6. So same like here, and it is 400, so this 400 10 to the power minus 6, this also same you have to do. And here the volume is 300 into 10 to the power minus 6, and it is divided by the temperature, and which is 300. So here this is it will cut, and it is coming 10 to the power minus 6. And here the volume is coming, this is 400, and it is multiplied by 10 to the power minus 6, and it is divided by the temperature. So the temperature is 400 Kelvin. So this 400 cut, and here it is coming 10 to the power minus 6. So this way you have to fill the table. Thank you very much.